my project. I guess I'll just kind of take you through my whole assembly process. Obviously the aesthetic isn't quite there yet. It looks pretty rough, as Hertzberg said, it's a rough aesthetic. So I'll use that. But pretty much my budget got really high really fast, so I couldn't add everything I wanted to. I wanted to make some sort of housing here, just to hide all the sort of the parts and the fasteners, but I was at like 150 bucks because my hand drill that I had at my house broke, so I had to get a new hand drill, and I didn't want to spend any more money for this class, so I used up my money pretty quickly, but it is very functional. So let's see, I started out with pretty basic materials you can find at McGuckin's. The only thing I ordered online was the motor for about $30. But besides that, it's PVC 2x4s. I pretty much walked around the whole store and tried to find whatever I could that would function properly on this instead of spending a ton of money ordering parts. So I talked with a bunch of McGuckin's employees. They sort of pointed me in different directions for what they think might have been able to work with this project. So we've got PVC pipe, a saw blade, a U-bolt. This is just a thin steel sheet, and then just a bunch of fasteners. So the blades there, it's a simple idea of how to make them, but when you actually have to cut out of the PVC pipe, it gets pretty tough. So I just draw straight lines all the way across. That's a 2-foot section of PVC, and then you connect the ends of the lines to create the blade shape. And so I bought a hacksaw to just cut them out, but that was not nearly strong enough. So I went back to McGuckin's, got sort of a smaller saw that I could be more precise with, and that was also not strong enough. It kept bending on me. So I had to come to the ITL and use just a massive handsaw they had. It took me about 2 hours total to cut these out. It's a pretty rough process. You just got to put all your muscle into it, and I was sweating a lot. It was tough. It's kind of hard to make it curve also with a handsaw down the PVC vertically. It's hard to get it out to come out like a blade, but I got to sand those down a little bit just to make it look a little more pleasing. So the other assembly I did here is just a U-bolt through the 2x4 to get the motor on there. And this is a wind vane, so it'll stay pointed towards the wind. And so I just drilled some screws into there, into the 2x4. It's a pretty sturdy sheet, so it works pretty well in the wind. I tried it out on Saturday when it was super windy in the afternoon. It does work, so I was happy to see that. And then in order to create sort of a bearing on the bottom, so if you wanted to mount it really high and have it be able to turn into the wind, I got this like Lazy Susan type ball bearing under here that I just screwed into the 2x4s just for presentation purposes, but you can mount this onto something tall and it would swivel pretty smoothly into the wind. So that was one of the things I was having trouble with, how to get that portion to work, but I found that bearing at McGuckin's after looking a while. So here's my cutting pictures of the ITL. Took me quite a while. And finally this whole assembly where I mount the blades on there and mount the saw blade onto the motor shaft, that was pretty tough to figure out. I found some online parts that would have worked like pretty custom with this saw blade, but the lead times on them were going to put me past the report date, so I had to kind of figure something out at McGuckin's. So one of the employees recommended just using epoxy because I don't plan on taking this apart. So I got a washer on here, and then this like double-sided female shaft I can just slide onto this motor shaft. And so I just put some pretty strong epoxy on there overnight, and it works fine. You can spin it fast, really no issues with it. So that worked out well. And then as far as putting the blades onto the saw blade go, the saw blade actually came with perfectly placed holes 120 degrees apart, so I was able to just put a nut and bolt through all those. That worked out pretty well. Yeah, so here's my budget. It got pretty expensive pretty fast after the hand drill. So I bought a couple hacksaws, which turned out to be useless. And I had to get a set of bits. I didn't have any good bits in my house, so that was about $15. It almost kind of added up quickly, so I wasn't able to complete the housing that I was hoping to, but it came out functional, which I'm happy with. I mean, the motor's pretty simple. It's just a DC output, so I was planning on hooking that up just to a voltmeter later today and just seeing what I can get out of it. But yeah, this is where I'm at right now. I would like to do more with it aesthetically, but the budget went pretty quickly, so yeah.
Consider using the motor and the saw blade to cut the
Huh?
Consider using the motor and the saw blade to cut the PVC.
I did not. Could have worked. I'm not sure if that would have been my best option, but maybe next time.
Something about the saw blade. When I saw you spinning that, it ducked out of the way.
Yeah, luckily it turns the safe way, relatively safe way. But yeah, it was like a $5 saw blade, so it seemed like a pretty simple option because it already had the holes in there. But it is a little scary looking.
Did you try any like different shapes of the blades? Like whether or not, and obviously it took a while to cut them out, but like, do you think if you were to try like a blade with like a wide profile, thinner profile? Like...
Yeah, so I was reading online and people have sort of used this technique before, and so you draw 4 lines down the length of the PVC, like 90 degrees apart, and I guess if you go all the way 90 degrees across down the PVC, it's almost too curved and too thick. So I cut out a couple of those, and they're kind of way too big, and they were curving like way up here. And I said, I guess that wasn't effective, which I was reading online. So I cut out a couple other sizes. This is about halfway. It's about 60 degrees through the PVC pipe instead of 90. That's if that makes sense. But I think that's the recommended sort of degrees you're supposed to go through on that.
Gotcha.
Yeah.
So what was the original aesthetic you were going to go for?
I was hoping to sort of get the function working and then create sort of a cool, sleek housing for it. Just sort of like an all-white appearance, just to cover all this stuff up. And I was actually considering using thicker PVC to just go around the whole thing, like a big white PVC. But like I said, at that point, I was already like $150 into it and still working on the function of it. So it came out to more of like just a very basic, make it yourself, pick it up at a hardware store aesthetic. You know, use all these different parts that don't really have a common theme, but they all sort of produce this clean energy solution. Yeah.
Where are you planning to mount it now?
So I just mounted it to the 2x4 just for presentation purposes, so you can see the bearing.
Yeah.
But yeah, if I can get this Lazy Susan bearing on the bottom onto some just thicker like wooden posts, and then like mount that. I think that's what I was trying to do at McGuckins, but they said they didn't have any wood at that point that was like had that type of cross section that I can mount it onto.
Like a railroad tie or something?
Yeah. Yeah. So.
Where do you get dimensional lumber in this town now?
I bet Home Depot.
Yeah, I go to Home Depot.
You got a Home Depot.
Yeah.
Yeah, they'll have like a 4x.
And they cut it down for you too if you need
Yeah.
it.
So that, I mean, it would be simple. I just drill that Lazy Susan bearing into there. So yeah.
I was just thinking that if it was closer to eye level for someone, you could do this really cool diorama with little workmen all over it. And,
Oh, yeah.
That would work with that aesthetic, I think. That would
Yeah.
be fun.
Yeah, definitely would be a good future iteration on this.
We're looking for the tour. The tour, they were here a minute ago.
Cool, good job.
Nice, sir.